Hello class, it's Miss Miller coming to you not live with another very exciting science PowerPoint presentation. We are doing physics. We're still doing optics. Today we're going to learn about mirrors and reflection. Questions of the week. How do mirrors work? What is a reflection? What changes how a reflection looks in curved mirrors or in water? These questions and more will be answered, hopefully. Plane mirrors. Is this a mirror that's on an airplane? No! A plane mirror is a flat, smooth mirror. And the image in a plane mirror is the same distance behind the mirror as it is in front of the mirror. The actual image will always be the same size as the actual object as well. The image that you see in a plane mirror looks real. It looks like there could be some opposite world inside of the mirror. You could step right through and be in the mirror world. As far as I know, the mirror world doesn't exist, but instead we're just seeing a reversed image of our real world. Now, it's not upside down, which is very useful for looking at ourselves in the mirror, but it is horizontally flipped or reversed from the real thing. If you've ever stood in front of your mirror wearing a shirt that has some writing on it, you'll see that the writing is reversed. And when you raise your left hand, it is your right hand in the mirror image that raised. If you wink with your right eye, it's the left eye in the mirror that winks. So they do get reversed, but not upside down, and the image is perfect. Fun fact about your teacher, Miss Miller, I can't wink. That's really upsetting that this is an example. Here's a diagram. Alright, so we got the lamp. Our source of light here bounces off the blueberry, bounces towards the mirror, and then bounces right into your eye. If we trace that beam backwards, you'll see that this mirror blueberry is the same size and distance from the mirror as the real blueberry, making it look perfect. One thing to note, we're not going to be getting out our protractors, at least yet for this unit, but the angle that the light hits a plane mirror and bounces off at is the same. So if we're coming in on this light beam here, which we would call the angle of incidence, it's hitting the mirror at this little angle here, right? It almost looks like a perfect 45 degrees, but I don't have my protractor out. And you'll notice that the angle of the light ray bouncing off, so the angle of reflection here, it is the exact same. And that's what makes the image in a plane mirror so perfect. But there are other types of mirrors too. We have a convex mirror that curves outwards, kind of like a bubble mirror going towards you. And the reflected rays from a convex mirror don't go straight, but they diverge. So they spread apart. So here's a little diagram here. A light ray is coming straight towards this mirror, but it's curved. So it bounces away. The light ray's coming here and it bounces away. At the very center, it bounces right back, right? But when we get to the curvy bits, it is bouncing away. And these light rays are never going to cross. They're never going to meet. They're getting farther apart from each other. And there are some uses for convex mirrors. They're used in those round security mirrors that you might see in a gas station or a grocery store. And they are also used in rear view mirrors and side view vehicle mirrors. Two main things to note about a convex mirror. The objects in the mirror are smaller than they appear, or they're closer than they appear because they appear to be smaller. More objects can be seen than in a plane mirror. It gives you a wider field of view than you would normally have. So we have like the supermarket here. You can see a whole bunch of stuff in this convex mirror that is bubbled out towards the viewer. And then here is a car, side view mirror, and you'll see that the objects in the mirror are closer than they appear because they appear smaller in the convex mirror, so that you can see more. And then the opposite to convex is concave. This is a mirror that curves inwards, and you can remember this because caves go in a mountain. Concave mirrors are used in spotlights, flashlights, telescopes, and makeup mirrors. So you have an example of a concave mirror that curves inwards. And this woman's hand is huge. It has been magnified. The light rays bounced off the curved mirror and meet at a single point called the focal point. Light rays come together at a focal point. They are converging. So the opposite of diverging, which means coming apart, is converging, which is coming together. So the light rays are going here, boom, and they are all converging on the single focal point. And then past that point, they begin to diverge. So a really interesting thing here is that if you're here looking in a concave mirror, you'll look super weird, but you'll still be right side up. But if you're back here and you're looking in a concave mirror, you're actually going to see the image upside down. And the reason for that is this. If we look at this top light ray and we follow its path, notice that after the focal point, it's on the bottom, right? If we look at the bottom light ray and we follow its path, after the focal point, it's going to be on the top. And so, if you have a distant object, an object very far away from the mirror, the image will be small, and more importantly, I think, it'll be upside down. Now, as you get closer to the focal point, the image will get bigger, because it's getting closer to the mirror. That makes sense. And then if it is inside the focal point, it'll be larger than the real object. It gets magnified, but then also it'll still be right side up. So we have a few little diagrams with that here. Here's an object that's far away from the mirror, and you can see that the reflection is going to be upside down and pretty small. As the object gets closer, the object reflection is still upside down, but it's bigger. And if that object is inside the focal point, then we have a nice big right side up reflection. All right. Here's a picture that was taken with me when I was on a trip. This is Haida Gwaii, BC. This is up by Toe Hill on a very beautiful, flat, smooth beach. And you'll notice that because of the thin layer of water over the sand, we are getting a nice, almost perfect, there's a few rocks and stuff that messed it up, but we're getting an almost perfect reflection of the sky. You can see the distinct shape of the clouds here reflected on the sand. And because this is a smooth surface, it's acting pretty much like a plane mirror, and we're getting all the light rays bouncing off at the same angle, giving us a picture that we can look at. The opposite example, as demonstrated here on this fishing boat, is that we have a bumpy surface, and so the light's getting reflected every which way, and so you get this distorted kind of reflection. I'll move back so that you can see it better. Yeah, it's the boat, but it doesn't make that nice, perfect image because the light isn't being reflected consistently. If you want to spot Miss Miller on the boat, it's me right here. All right, and then I have one more cool picture to show you. Look at this majestic eagle. I can't believe that I got such a good picture of this eagle on Balance Rock. You're right, it is unbelievable because this is a fake image. Did I get you? Maybe. And the reason why I wanted to bring fake images into this is because you can actually look at shadows and reflections to determine whether an image has been faked. For example, if we look at this eagle, where's the light coming from? Right? We can see the shadow on the side of its body and on the back of its tail. It looks like the light is coming at sort of this angle towards the eagle. But then if we look at the rocks, we can see that the shadows are underneath. It's looking like the sun is back here. It's pretty high in the sky, maybe around lunchtime. And these don't match up, right? So unless someone's shining a spotlight on the eagle, it's a pretty good clue that this image has been faked. And it has indeed. I photoshopped this eagle onto the picture of Balance Rock. So, I bring this in because I think this is a fun little application. And in your assignment, we have a couple of questions about mirrors. We have a fun little experiment that you can do that involves some science yoga. If you have no idea what I'm talking about, you'll read it. It's kind of just a little silly mirror thing. And then we have a question where I've given you another picture that I may have photoshopped a little bit. And I'm getting you to tell me what you think is real and what you think is fake. And I want you to back up your argument by telling me about shadows and reflections. All right. This is a quick one. Hopefully you guys have a nice day. Ask me any questions that you have anytime, and I'll get back to you. And yeah, not so good at the outros.